Hey guys, so I thought I would go back over the differentiation under the integral sign business that we did because I know it was quick. And this way you'll have it. It's a fun technique. Use it to impress your friends. It's just a nice thing to know. It's not all the time going to be useful, but it contains some cool math. Okay, one more time. Have it in your notes. But we'll go through it again. Okay, remember that we were after an integral. We want to do this integral. The integral from 0 to infinity of r to the 4 e to the minus r over a naught dr. Okay, now notice that there's no u substitution that's going to work for this. Okay, you'd have to go look this up, and you can, right? But the way that the answer to this integral was derived, and in fact, the answer to all integrals of this form was derived in the following way. We're going to show you that again. So for instance, e to the minus r over a naught, right? This can be any constant, this one over a naught, right? Okay, dr, and we know that the answer is n factorial a naught to the n plus 1. Okay, so that is the answer, but the way this was derived was by doing this special technique. Okay, so let's take a look at it again. Okay, we did this in class, but all right. So I want to point out here that we have an integral I0, okay, that is a really easy integral to do. It is the integral from 0 to infinity of just e to the minus r over a0, okay? In our problem, it's a0 is the Bohr radius, okay, dr. This is a really easy integral to do. And if you, let me move my pictures right in the way of everything. Let me make this smaller and just move it out of the way. Okay, you can't see that, but I can, it's bugging me. All right, there we go. All right, so, so to do this integral, we make a u substitution right here. So let's say u is minus r over a naught. So du is equal to minus 1 over a naught dr. Okay, okay, so that means that we can replace dr with minus a0 du. Okay, so here we go. So minus a0, and then we have the integral e to the u du, which we know how to do because, of course, that's just e to the u is the answer to the integral. So minus a0 e to the u, and we're going to substitute back in for u, minus a0, and then we have e to the minus r over a naught between 0 and infinity. And this gives us minus a naught, and then e to the minus infinity minus e to the 0. E to the minus infinity is 0. And this becomes, and e to the 0 is 1, sorry. So this becomes minus 1. So we get altogether a0 is the answer for this. And I'm going to keep track of that in a little table. Okay, in a little pink table. I'm going to move this out of the way. So we have I0 here, okay? There's a little table. So the integral and the answer. Okay, and that's a0. Now let's check this against what we know is supposed to be the answer, right? So in this case, n is 0. So we have a 0 factorial, and in fact, 0 factorial is 1. a0 to the 0 plus 1, in other words, a0 to the 1, which is a0, so that checks, right? All right, now, let's, we're after all the way r to the 4th, right? Well, okay, right now I can't really do anything. I just showed you a cool integral I0. All right, let's look at I1. Okay, so what is I1? And I should have done some color coding here. Let me you can fast forward here while I just meant to do my color coding. So give me a second. Give me 1 second while I correct this. Again, you can fast forward through this if you don't like it. Okay, so I0 is A0. Okay, all right, so let's look at another integral, kind of getting our way up to I1. I'm sorry, this is going to be I4, right? So I1, and that is the integral is when n is 1 from 0 to infinity r e to the minus r over a naught dr. Now, again, no use substitution will work here. So here it worked because we don't have an r when we're able to do this integral. We now are not able to do this integral without using this formula, which is what we're trying to get to. Okay, can't do it. Okay, now here's where the trick comes in. We're going to take the derivative of this function. So we're going to take the derivative, so d with respect to 1 over a naught of e to the minus r over a naught. Okay, now remember, this is with respect to 1 over a naught. Okay, so if this is confusing to you, think of 1 over a naught as b. Okay, and that would be, then we would have d db of e to the minus rb, right? So d of this function with respect to b would just be minus r e to the minus rb, right? Same thing here. The derivative with respect to this function, with respect to 1 over a naught, is just going to be minus r e to the minus r over a naught. Now notice, this is the integrand we need here. Okay, so I'm going to substitute that in here. Okay, so here I have 0 to infinity, and I'm going to put in that this guy here, the integrand without the minus sign, is this derivative. So this integrand here is negative the derivative. So we have a negative sign I'm going to pull out here, and then we have dE to the minus r over a naught d 1 over a naught dr. And here's the thing. This derivative is with respect to 1 over a naught. It does not care about this integral. It doesn't affect it whatsoever, meaning I can pull this derivative outside of the integral sign, okay? Because it's taking a derivative with respect to something that the integral doesn't care about. The only thing the integral cares about is r, okay? So here we go, we're gonna pull it out. So we have minus d1 over a naught of the integral 0 to infinity e to the minus r over a naught dr. And that is the integral I naught, right? So this is d1 over a naught, and switch colors, of I naught, right? So this is the derivative of the integral I naught, right? With respect to 1 over a naught. Now we know what the answer is, so it's actually equal to minus d with respect to 1 over a naught of the answer for I naught, which again is sticking with the color coding, which is a naught. Okay, so what do we have? We have, stick with the green now. So we have the derivative with respect to 1 over a naught of a naught. Now this is a little confusing. You can certainly figure it out if you think about it hard enough. I just like to use easy things, so I use the chain rule. So I'm actually going to just look at this operator. So I think about this guy here as being an operator. So I'm going to just do that in my blue color because it's going to be something I'm going to use over and over again. So I'm going to look at my operator. So I have d d1 over a naught. I want to change that into something that's dd a naught because it's annoying that it's dd1 over a naught. Okay. So, all right. So I'm going to use my chain rule to do that. So I know that I want to get rid of this. So I know I'm going to have a d1 over a naught on the top. And I know that I'm going to have, let's see if I always do this wrong, right? I told you that in classic. I always do this wrong. Yeah, there we go again. Yes, it would be nice if I didn't do it wrong every single time. Okay, one of these days I will get it right on first try. Let's see. Okay, so we need to, we want to be left with, maybe this is the way to think of it. We want a DDA naught. Okay, yeah, there we go. So I put the DDA naught because I basically multiplying by DA naught, right? And then the D, there we go, okay? Because this is the same as this because this cancels this, right? The DA naught cancel. Okay, now what that does for me is that gives me an operator now that allows me just to take a derivative of something with respect to a naught. Now I got to figure out what that is first. And that looks just like that, doesn't it? So maybe I didn't have to do that, but I just can't get my head around things. Okay, so we could have actually just done this, but yeah, no accounting for my brain. Okay, so what we're gonna do is look at this. Now this is just, this derivative is just d1 over a naught, dA naught, right? And so to the -1, so you can flip that around, right? Okay, so we know what this is, this derivative. It's just minus 1 over a naught squared to the -1. So it's minus a naught squared. Okay, yeah, we could have done that here, couldn't we? Okay, anyway, but it's nice to have this operator. Okay, so, so this operator is minus a naught squared d a naught. Now I don't have to think anymore, right? Because I've got this. Okay, so now back to my green. And green, yeah, okay. And then we're going to apply it, right? So this dd becomes minus a0 squared dA naught, which as we know is 1. So this is just minus a naught squared, as of course we knew that because I just did that, right? Anyway, but having the operator will be useful, promise. Okay. Okay, so now this is the answer to this, except there's a minus sign, notice, right? See the minus sign over there? So that takes care of this minus sign, and now we can write down our answer to I1. So I1, the answer is a naught squared. Okay, let's see if that works. So n here is 1. So we have 1 factorial, which is 1, a naught to the 1 plus 1, which is 2. Yes, we got it. Okay, so let's go on. Let's look at I2. And I2, well, this nice purpley color. So I2, let's figure out what that is. So I2. Okay, so we have the integral from 0 to infinity of r squared e to the minus r over a naught dr. Again, you'd have to go back to this formula, and so we're trying to build our way up to sort of infer this formula. Okay, all right, now we need to figure out what derivatives we can take. Well, notice over here, when we took the derivative in the green one up here, right? The first derivative is minus r times this. Now, what if we take the second derivative of this, right? Or the first derivative of this, right? So let's take the second derivative here. Okay, so we have let's take the second derivative. Here we go. D squared e to the minus r over a naught. Let's see, is that what I want to do? I think it's easier. Give me a second here. I think it's easier not to do that. what we're going to do is we're going to just take the second derivative of this function here is this. So we're going to take a derivative d1 over a naught of minus r e to the minus r over a naught. Okay. Now remember, this is with respect to 1 over a naught. It doesn't care about r. R is like a constant. So it's going to be minus r times minus 1 over, no, sorry, minus r again. Oops, let me mess that up. About to say minus 1 over a naught. That is not correct. Minus r again, right? E to the minus r over a naught. So that becomes just r squared e to the minus r over a naught. Okay, cool. Notice that now I have the derivative. So I have the integrand, I have the integrand in the purple integral. Okay, so we can replace this again with a derivative. So we have the integral from 0 to infinity, and then we place this with a derivative, d r e to the minus r over a naught with respect to 1 over a naught, and then we have dr, and we pull it out again because we can't, but I'll pull out the derivative. And then we have the integral, we have a minus sign here, right? The integral r e to the minus r over a naught dr. This is the integral I1. So it's minus d1 over a naught times I1, okay? I know what I1 is. It's a naught squared. So it's minus d1 over a naught of a naught squared. Now, I'm going to use my operator again here and now put in here, right? So this becomes minus a plus, right? Because I have minus here and a minus here. A0 squared d a0 squared dA naught. Or a naught squared dA naught. Okay. And so this derivative is 2a naught. So we get 2a naught cubed. This is 2a naught cubed. Again, when n is 2, we get 2 factorial, which is 2 times 1, which is 2. A naught to the n plus 1, 2 plus 1 is 3, and we got it. Okay. All right, we are on our way. I'm going to do one more for you, and then you are going to, if you choose to, you can do the last one, the one we want here, and show all your work, okay, for extra credit. All right. Oh, now I want to get my pink color to get back from my table. Okay. All right, so let's use a nice red. Okay, so we're going to do I3 now. Okay, so I3, as you might imagine, here I3 is equal to the integral from 0 to infinity of r cubed e to the minus r over a naught dr. Okay, and now notice if we take a derivative of this, right? Another derivative, we'll get an r cubed here, which will be nice. So let's do that in the red here. So d1 over a naught r squared e to the minus r over a naught. And that's going to be minus r cubed e to the minus r over a naught. Yeah, okay, and that of course is our integrand with a minus sign. And so we'll put that in. So minus the integral 0 to infinity of d dA naught, oh, d1 over a naught, sorry, I don't know why I misspoke there, of r squared e to the minus r over a naught, and dr. And so I pull out the derivative once again. So we get minus d1 over a naught, and then the integral 0 to infinity r squared e to the minus r over a naught dr. And so we know that this is I2 minus d1 over a naught of I2. Okay? And we know the answer to I2 is 2a naught. So we get equal minus d1 over a naught of 2a naught cubed. Again, we use our operator right here. Okay, so we get, this is going to be minus minus, so plus. So we have plus a naught squared d a naught of 2a naught cubed. And finally, we get a naught squared, and then we get 2 times 3, right? 6 a naught squared, which altogether is 6 a naught to the fourth. So it's 6 a naught to the fourth. So when n is 3, we have 3 factorial, which is 3 times 2 times 1, which is 6. A naught to the 3 plus 1, which is 4. And there we go. Again, I want you guys, for extra credit, and show every step of the way to prove that this one gives you 4 factorial a naught to the 5th. Okay? All right. Good luck.